Hi, my name is Michael Ruiz. I go to K-Free Community College, and this is my Matlab semester project. The course I attend is Engineering 214 Numerical Methods for Engineers, semester spring 2022, with instructor Dr. Hans Chapman. The related course to my Matlab project is Calculus 3, section 16.6, Surface Integrals. Some relevant formulas used in my Matlab project is the general surface integral formula of f of x, y, and z. The surface integral given by z equals g of x and y. The parametrized surface integral of f of x, y, z of a parametrized function. Some notation to take out of this is a partial derivative with respect to x, partial derivative with respect to y, parametrized function of r, of u and v, and the cross product of the partial derivative of r with respect to u and the partial derivative of r with respect to v. In order to simplify surface integrations, taking a look into the bottom left image, we'll be looking to integrate a surface S over any region, in this case, a region of D. This is an overview of my project. The purpose in making the script is to solve surface integrals efficiently. Surface integrals are used throughout the world, such as to determine pressure and gravitational force, or used to calculate the moment of inertia or the center of mass of an object. I simplified the variety in surface integration and focus on certain methods. I start with the prompt of defining what type of surface the integral is bounded by. The script follows the user's input, such as parametrically, explicitly, or rectangular. Further input may be required depending on the user's problem, and not only desired to provide an answer to surface integrals, but provided a graphing aspect towards it. Taking a look into example problem number 1, evaluate the double integral of f of x, y, and z using a parametric surface given f of x, y, and z equals x squared plus y squared, and S is the hemisphere x squared plus y squared plus z squared equals 1 above the xy plane. We need to find the surface integral of f of x, y, and z bounded by the surface of S. We are given f of x, y, and z equals x squared plus y squared. We are also given S, which equals x squared plus y squared plus z squared equals 1. For this problem, we will use the parametrized surface integral formula. Beginning with our calculations, we will transform x, y, and z into functions of u and v. You see, we get r sub u and v equals sine of u cosine v, sine of u sine of v, and cosine of u. We take the partial derivative with respect to u and the partial derivative with respect to v. We take the cross product of r sub u and r sub v and find the magnitude, which equals sines of u. Substituting r sub u and v into the function of f of x, y, and z, we can now plug it into the surface integral. Given a surface S, the hemisphere x squared plus y squared plus z squared equals 1, we get the region of 0, negative pi over 2, 0, and 2 pi. Completing the surface integral, we get 4 pi over 3. Using Matlab to solve this problem, we'll look to integrate x squared plus y squared. We're then followed by another prompt asking us to define a surface parametrically, explicitly, or rectangular. We'll enter 1 for parametrically. We're then followed by another prompt asking if g of x and y and z is already parametrized. We'll enter no. We're then asked to input the lower limit of the u region, upper limit of u region, the lower limit of v region, and the upper limit of v region. We're given the answer 4 pi over 3, followed by more input asking us to enter the surface x squared plus y squared plus z squared minus 1. We are then asked to enter the lower z value to view the graph. We'll enter negative 10 and insert the upper value to view the graph, which will be 10. We are now given the graph in which we will see the surface in green and the function of x, y, and z parametrized in blue. Looking into example problem number 2, we are looking to evaluate the double integral of z plus 3y minus x squared, where s is the portion of z equals 2 minus 3y plus x squared. that lies over the triangle in the xy plane with vertices 0, 0, 2, 0, and 2, negative 4. We are looking to find the surface integral of f of x, y, and z bounded by the surface S. We are given f of x, y, and z equal to z plus 3y minus x squared. We will use the surface integral formula when surface S is given by z equals g of x and y. Starting with our calculations, we substitute z in the function of f. Given the vertices, we can draw a graph of where the region lies. We obtain the boundaries of negative 2x to 0 and 0 to 2. When integrating, we get an extensive answer of 26 to the power of 3 halves over 3 minus 10 to the power of 3 halves, which equals 33.6506. Using Matlab to solve the problem, we'll input the function of z plus 3y minus x squared. The script directs us to a prompt of how to define the surface integration. We will input 2 for the explicit surface. The next prompt that follows is whether the user would like to integrate x or y first. Typically it doesn't matter, but Matlab would incorrectly integrate if a region was bounded by a function of x or y with the wrong order. We will follow dy first. Our next input is enter the surface in explicit form of z equals f of x and y. We will input z equals 2 minus 3y plus x squared. The lower limit of the y region will equal negative 2x. The upper limit of the y region will equal 0. The lower limit of the x region will equal 0. And the upper limit of the x region will equal 2. We are given the extensive answer equal to 33.6506. Lastly, we will enter the z values in which we wish to view the graph, and we will enter negative 10 and 10. We can take a look into the graph and view the surface along with the function of f. Looking into example number 3, we are looking to evaluate the surface integral of the vector field f equal to 3x squared I minus 2yxj plus 8k over the surface S, that is the graph of z equals 2x minus y over the rectangle 0 to 2 by 0 to 2. We are instructed to find the surface integral of the vector field f over the surface S over a bounded rectangle. We are given f equals 3x squared I minus 2yxj plus 8k and S equal to z equals 2x minus y by the rectangle 0 to 2, 0 to 2. We will use the general formula of integration with the twist of utilizing the dot product between the surface S and the vector field f. Starting on our calculations, we use the dot product between vector field f and the partial derivative of z in the respective order of I, j, and k. Completing the dot product, we result in f of x equal to negative 6x squared minus 2xy plus 8. We now have our surface integral with the region of 0 to 2 by 0 to 2. We receive an answer of 8. Using Matlab to solve our problem, we input the function of negative 6x squared minus 2xy plus 8. We finally select the rectangular section of the script. The prompt directs us to input the region. We enter 0, 2, and 0, 2. We get displayed with the answer of 8. A graph pops up with the function of f in color green and the region of which it is bounded by in red. A review into my Matlab project. My Matlab project was a small example of what can be done for surface integration. Surface integration is used in areas of engineering to compute values such as determining an electric charge distributed over an area or to compute an electric field. This script was a good attempt in generalizing the surface integral with how many approaches is used. Some improvement areas that I feel were needed were graphing the parametric boundaries and including more parametrization.